Okay, class, so I'm just going to go through the review packet here, sort of. You can always press pause, remember, sort of rewind, because I'm going to go pretty quick to be able to get through the whole thing. And I'm going to break it down by page too, so each video is going to be one individual page, okay? So starting here at the beginning, prime factorization of 90. If we want to find a prime factorization, that's where we start doing the tree thing, as most of you call it. So 9 and 10, 3 and 3. 2 and 5, again, you could split it down as long mathematically it's correct. We should still end up with 2, 3, 3, and 5. Okay, number 2, we're looking for the GCF. So something that goes into 8 that will also go into 16 is 8. They both have the x, so smaller exponent is 4. They both have the y, smaller exponent is 3. They do not both have the z, so we can't pull that out. And then remember, it's always a good idea to divide to make sure you didn't miss anything. So 1, the x's cancel, y squared z, and 2, x. Yep, so nothing goes into 1, that also goes into 2, nor do they have any common variables. So 8x to the 4th, y to the 3rd. Number 3, our GCF for all 3 of those, they don't have anything in common. So if there's nothing, right, our real GCF is actually 1. So for number 3, our answer should just be 1. Number 4, we're going to factor. We always start by looking for a GCF. This has a GCF of 5x. So when we divide that out, that leaves us with a 2x squared plus 5. Nothing will go into 2. That also goes into 5. It's not a special case, so we're finished there. Number 3, again, we always start by looking for a GCF. So 7, 35, and 49 have a GCF of 7. They all have an a, smaller exponent is 2. They all have a b, so if we divide that out, that will leave us with 1ab, 5a squared, 7b squared. Nothing will go into all of those. It's not a trinomial. So there's our final answer there. Number 6 is 4 terms. So to factor 4, there's not a GCF, so to factor 4 terms, we're then going to split it in half. Over here, we have a GCF of 2x. Okay, when we divide that out, so it leaves us here. On the right-hand side, we have a GCF of b. So we'll put our GCFs together. So we'll get a 2x plus b and an a plus 3c. Number 7 is a trinomial. So we'll take 1 times 24, which gives us 24. Then we'll list our factors, 1 and 24, 2 and 12, 3 and 8, 4 and 6, 5 and nothing. Because this is a negative, that means we need them both to be negative. So the only option we have is when they're both negative. So the set then that adds up to 10 is -4 and -6. So I have x minus 4 and x minus 6. We can use the shortcut because a is 1. Number 8 is also a trinomial. A is 1, so we can use the shortcut. So 1 times 9 is 9. Multiples of 9, 1 and 9, 2 and nothing, 3 and 3, 4 and nothing, 5, right? That's it. That's our list. Okay, so the set that adds up to 10 is 1 and 9. We need everything to be positive, so we'll use x plus 1 and x plus 9. Number 9, 1 times -44 is -44, so we'll start listing our sets. 1 and 44, 2 and 22, 3 and nothing, 4 and 11, 5 and nothing, 6 and nothing, 7, 8, nope, nothing else. So we need the larger number to be negative. So here's our set right here. So we'll have an x plus 4 and an x minus 11. Number 10, a does not equal 1, so this is not a shortcut. So 12 times -1 is -12. So we'll list our factors. 1 and 12, 2 and 6, 3 and 4. Okay, we have a positive followed by a negative, so that means we need our larger number to be positive, our smaller one to be negative. we're going to choose this set here, but it's not a shortcut. This one we have to rewrite into 4 terms. So we'll have to say 12x squared minus 2x plus 6x minus 1. GCF. Over here we have a GCF just of 1. So that's a 2x plus 1 and a 6x minus 1. So mine's in a different order, right? But order doesn't matter. The answer is still D. Number 11 is 2 terms. It does not have a GCF. So the next thing we could consider is a special case. So 2 times 2 is 4. Half of the exponent is 1. 9 times 9 is 81. So we'll get a 2x plus 9 and a 2x minus 9. Same thing on 12. No GCF. It's 2 terms. So we could consider a special case. So 11 times 11 is 121. So 11y plus 5x and 11y minus 5x. Okay, so 5n squared minus 45n, if we factor that completely, so we're going to look for a GCF first, as a GCF of 5n. So that gives us 5n times n minus 9. We cannot factor n minus 9 any further. It's not a special case. So one of our factors would be b. Okay, 14, we want to find one that can be prime, so we're going to have to go through and sort of factor each of these and see which one we can't factor. So A, we can factor because we could pick multiples of -2 and -2, so it can't be A. B, let's see, 1 and 24, 2 and 12, 3 and 8, 4 and 6. Let's see, we want the larger one to be negative, so we could pick 4 and -6, so it can't be B. C, 1 and 7, right? Nothing will add up to 6. If we check D, right, 1 and 2 will add up to 3. So our correct answer here should be C.